All right, descriptive geometry, problem 2G, A and B. And we're dealing with slope and bearing. And this is something you really have to understand, a concept you have to be able to get to be able to go farther and do more of the problems, because bearing and slope are very important. And as we've gone over and discussed before, slope is essentially dealing with like the pitch of your roof, the slope of the grade that's going through, the slope of the road, different things such as that. You need to build a ramp that has a specific slope. If we're trying to match, let's say, a bridge up with the land, we need to make sure that we don't have too large of a degree or percent of grade or too large of a slope that it makes it hard and unsafe for vehicles to get up and over it. So there's lots of different practical applications here. So here's a couple things we need to go over. One, azimuth and bearings. So you have your compass bearings, and then you have your azimuths. Azimuth deals with degrees. Now, this is where students get a little confused when they do the azimuths. They would measure, let's say here, and they know that this direction from here to here is 45. So they would want to write that answer as 45. It's not, because it's going counterclockwise, so it continues to grow. So if I was doing it to here, that's 135. If I was coming over to here, that's 270, 315, and so forth. So you have to deal with your azimuths. Bearings deal with north, south, east, west, just like in a compass. They're slightly different in that you have to, one, find what direction you're going. So if I'm coming down and to the right, that would be southeast. And then I would have to find the actual angle. And so I'd have to look here. I know that in this little quadrant right here, it's a 45. And so I would actually like turn it around and look, and I would measure, pretending this is north, that this is north, and angle here to 45. So that's how those work. So let's show you how we do some of this. Okay, to start off with, I'm actually going to come in here and block all these off into little coordinates. Before I even start doing any measurements or anything, I'm going to block them off in essentially their own little rectangles. Makes it a little easier to do and draw. So step one, find that straight line and use my straight edge. And I will probably have to come back and draw these lines out even more here in a minute. Right now, just to get started. So I've lightly drawn all my lines. I've done that to make it easier for me to use the protractor to measure things here. So let's start off measuring. I'm going to go ahead and measure my angles, and then I'll come down here and I will do what this is, and then we'll go back and reference to the angles, and we'll go through that. Okay, so here's my protractor. And if I look here, the angle to 1 to 1 is a perfect 90-degree angle, right? So it's just 90 degrees. It's just plain old 90-degree angle. Okay, not a problem. Now we want to find 2 to 3. How am I going to find that one? I'm going to spin it around north here, and I'm going to line everything up. So I'm lining protractor up with here to here, and I need to find that angle. And then I realize, oh goodness, I need to draw that off so I can see it. So I'm just going to spin it around so I can draw the line out, so I can actually see and line it up. There it goes. So this one, it's showing, there it goes. So 10, 20, 30, 40, 50, 60, 61, 62, 63. So here to here, 63. If this is 63, well then this over here has to be 27, because you have to be able to add them together to equal 90. Some basic math, going back to high school, basic geometry. Same thing again. Let's project it out so I can actually line it up with the protractor. There it goes. Okay. 10, 20, 21, 22, 23, 24. 24 degrees. So this side is 24. If this side is 24 degrees, then this side has to be 66 degrees. again, because dealing with, they have to totally equal 90. Let's do 4, 5. So if I look at it and it comes right at 40 degrees, 50 degrees. And if I look at 5, 1 and I drew 5, 1, it's 90. It's just a straightforward straight line. All right. So I did all that so that I could find the angle so I could start doing the next part here that goes in. All right, the next part, before we start placing and figuring out what the angles actually are, let's figure out the direction we're going to go, because that's what's going to affect the north, south, east, west, etc. So we need to find the actual bearing. Which direction are you bearing? Which direction is it going? So again, here's your bearings. So 1, 2 goes straight up. So it's just plain north. All right. 2, 3 goes up and to the right. That's northeast. 3, 4 comes down and to the right. So that's southeast. 4, 5 comes down and to the left. So that's southwest. Now let's get those angles that we're actually dealing with. So if I look at my little example that's given to you down here, if I'm measuring up and I'm going this direction, I need to know what's the angle in this quadrant here. So if I'm measuring here and I'm measuring up, it's 63. So I know that that 60 is not actually right. It's actually 63 degrees. Okay, so then this next one here, I'm going to turn it so that I can look at it as if I was looking at that with north going up. So north is going up and it's going this way, so that tells me it's 24 degrees. Same thing with 45, I need to find 45, so I'm going to turn it up as if I was dealing with north. What direction it's going? Well, it's going 40. And then 5 to 1. 5 to 1 is just going plain straight west, and it's not going on any degrees. It's just plain 0 degrees. It's just going straight in the line. All right, so then we're going to come over here to these. And they're all going to be referenced to north. So angle 1, 2. Looking at my azimuth, it's going straight up, so it's going to have a north 0 degrees. If I'm looking at our next one going as a reference to north, it's actually yeah, 63 degrees. Because what you have to do is you have to remember that this would be like 0, and this says 90. 180. So you kind of have to remember those things as you're dealing with each and every single one. You have to deal with it separately. Okay, we're going to deal with 3. So that same thing, this would be 0, 90, 180. So I'm looking here and I know, okay, it goes completely to here is 90. 90 plus the 24, it's 114. So that's its azimuth bearing. Okay, let's do 4, 5. Same thing, 0, 90, 180, 270, so 0, 90, it's 180. 180 plus 40 is 220. And then the same thing with 5 to 1. And if I had this drawn here, 0, 90, 180, 270. So that's why it's north 270. Okay? All right, now problem 2, you're going to have to first find the true length of the line. You know how to do this. And then you need to find your rise and your run. So you would continue to bring it out. So first thing I did is I found the true length of the line, 5, 6. So this is that true length of 6 to 7. I then continued it over so I get the full triangle. You have your rise and your run that way. And then we're going to do the math. So let's do, hang on one second, brain fart. We're going to go get our formulas real quick. So I know percent of grade is rise over run times 100. I know slope is the negative 10, the negative theta of the angle. So I know to get that, that would be rise over run That'll give me my 10. And then the slope is actually equal to -10. So that's when we have to use our calculator. And then our compass bearing. So we want to find out which direction, etc. What is it going? So let's start off with a couple of things here. Let's go ahead and write down our compass bearing, and then we'll figure out our angle. So 5, 6, if this is north, because it is north right here, 5, 6 is coming just slightly, and I do mean slightly, if I have this lined up, slightly down and to the right. So then it's going to be, yeah, southeast. Okay, percent of grade is rise over run times 100. Get our calculator. So we have a rise of 1.1 over 2.6. So I know my tangent on this one's going to be .42. So 0.42 times 100, well, is 42. And then I'm going to do a -10 of the 0.42 to get the angle, which in this case is, let's go ahead and round it up to 23. And now let's find our compass bearing. Now how am I going to find my compass bearing? I have to repeat that process of creating those perpendicular lines and blocking in to get it. Because I have to pretend like this is 90 on the corner here, because it should be the north going straight up, and we're going to go from there. I'm going to try to get it right on here using this. Come on, line up. There it goes. Yes, you make it, yeah. Nope, I gotta get that line. It's kind of hard to read without. So straight edge again, line it up, that parallel line. Dang it, move it. So I'm trying to get that north, I'm trying to get that 90. There, okay, that's better. Okay, so I have 10, 20, looks like 24. So here to here would be 24 degrees. And if I know that that's got to be the 90, then 24, that would be 66 degrees. Because again, it has to equal 90. Some basic math we have to know. So when I look at it here, from here to here is 24 degrees, here to here is 66 degrees. So compass bearing is 66 degrees. Because if I'm standing here looking at it, which direction is it going? 66 degrees. All right, and then you would of course come down and complete the title block, fill in your state, the date, drawing number, etc. So go over it and mark it, make sure it's nice and dark. All right, next we're going to do the second one, GB.